Here we go.
Cool.
So, hi everyone. My name is Rob Canzaneri, and I'm with the with PASS and the Data Architecture Virtual Chapter. I'm really glad you're here today. Today we have Grant, and he's going to be talking about getting started reading execution plans, which I think is a great topic. Um, let me see. So, PASS has lots of virtual chapters, and this is a slide kind of showing you some of the virtual chapters, maybe all of them. And there's always something out there for y'all to join, see. Like they're all great chapters, and they have webinars every month. So here are some of the current webinars in this month in November, and we're one of the first in for the month, so you can see the other upcoming ones. And they, you know, if you want to, if you see a topic you like and you want to get involved and watch it, just sign into that virtual chapter. For example, you can go into like Excel, and they'll have a link, and you can see their webinar. So, Pass also supports SQL Saturdays, and here's some upcoming SQL Saturdays. And just if you're in Tampa or Montreal, sign up. I mean, it's great. It's great education, and it's um, if you want to volunteer, here's some great ways to volunteer and go to Pass and meet people. They have local chapters, and there's the link for the local chapters. And if you, here's the link for the volunteering. So you can go to the volunteer.sqlpass.org website, and if you want to volunteer, that's how you go about doing it. Just a few other words today. The session is recorded, and it will be posted at the data architecture section under SQLPass.org. And I also have a blog, and I posted on my blog a link to the YouTube. So there's two ways to get to it. If y'all want to get in touch with me, or y'all ever have questions, y'all can email me. My email is rob@sqltigers.com. So with all that being said, thank you, Grant, for being here today.
Thank you.
And I'm gonna switch it over to Grant right now, and we'll see if everything goes smooth.
Okay.
And
All right. Just to verify, you should see my screen.
yes, I can. And we're about 135 attendees right now. Just
Excellent.
so you're in the know, or it's climbing 136. Look at that.
Okay. Just let me know what the max is at the end. We'll be all right.
Oh, you got it. So,
Cool. Thank you.
all right.
All right. Well, let's go ahead and get started here. Let's talk about getting started reading the execution plans. Um, hang on. Nothing happened. There we go. So I've got some really simple goals. The main takeaway, the main thing I want you to understand at the end of this session is where to get started. Execution plans can be insane, really crazy insane, and they can be very confusing, and there's just a lot of information there. And so the main goals here are simply to provide you with some start points to show you not best practices necessarily, but just good places to go to get information so you can begin to understand the mechanisms for drill through, the mechanisms for drill down, the various places to go to get the information so you can start to put together how to read these execution plans. It's not that hard once you've done it a few hundred times, but that getting started point, that's where it gets a little rocky. So the whole goal of today is to get you started, to give you some places to look, some ideas, some general topics, things that you can pursue quickly and easily that'll get you started and give you some ideas on what you're looking at. Now, my name is Grant Fritchey. This is my blog, my email, my Twitter handle. Please, please, please feel free to get in touch. I answer my emails. If you have questions about execution plans, query tuning, any of that fun stuff, I absolutely will get back with you about that. Just ask whatever you need. These slides are already online at SQL Share. I'm sorry, SQL Share at slideshare.com, and I'm here to help out if I can. So you've got my contact information. I'll put this up again at the end just in case. So you guys all came here today to listen to me ramble on about execution plans, but the real question is why? Why would we care about these silly looking things called execution plans? And the answers are pretty deep, believe it or not. There's a lot more to it than you think. But if you've got an issue with your code, if you've got, poor code choices, they are made. People do make poor choices with T-SQL occasionally. If you've got some structural problems, either you haven't normalized your databases properly, or there's missing foreign key constraints, or you could use some other types of constraints or rules inside your database, um, or you've got out of date missing statistics, horribly skewed statistics, any of these things that cause performance issues inside your database, you're going to want to look at execution plans, because execution plans are the window we have into how the optimizer is behaving. Now, the query optimizer is a thing that takes the T-SQL that you've written, runs it through the engine that determines how best to retrieve the data that you've asked for, or to insert the data that you've added, or update or delete data. Every one of these commands requires what's called an execution plan, and that execution plan comes from the optimizer. Now, the optimizer makes a whole series of choices. Do I have an index I can use? If I do, can I scan that index, or can I seek against that index? All of these things come from the optimizer, and they're all evidenced in the execution plan. And so our execution plan is really the single window we have into what happened. Why is this query behaving the way it behaves? That is why we have execution plans. And so presumably you're here today to get started reading execution plans, so let's talk about that. Now, execution plans actually come in two flavors, but that's a lie. I want to say it up front. You can get an estimated execution plan, or you can get an actual execution plan. And there's a whole bunch of ways that you can get them. One way is you can manually generate them yourself through Management Studio. I'm going to demo that today. You can also pull them directly out of the procedure cache, and I'll show you how to do that as well. You can also capture them using extended events if you're running SQL Server 2008 or better. If you're running 2005 or less, you're not going to be able to do this. You'll have to use trace events, but I strongly recommend against using trace events. These are very, very intensive processes. If you run queries and you're capturing execution plans using trace, you're going to be putting a lot of excess load on your system. Generally, if you're trying to capture execution plans, it's because you've got performance issues. Adding the overhead of trace to an already suffering server can be a problem, so I very much recommend against it. Now, the two types of execution plans we have are estimated and actual, and you can see on the slide there what I've done is showed you where you get each of those types of execution plans. Now, the interesting thing is that there's really only one execution plan. It's not that there's an estimated and an actual. What there is there's an execution plan, and the estimated plan represents what would be the execution plan. An actual plan is the estimated plan plus about 6 or 8 different parameters that are captured. I'll show you what those are when we do a demo. And that's really the only difference between the two. The place where you may see radical differences between an estimated plan and an actual plan are in cases where you have a recompile event. But without the recompile event, estimated and actual are almost always going to be identical, except for a few little extra properties. However, that said, what do you want to get, estimated or actual? Most of the time, you're going to want to get actual because of those extra properties. They're very, very useful little bits of information. We're going to go over what they are. I'll show them to you. But they're important. However, don't shy away from what they call the estimated plan. It makes it sound like it's, well, this is just a guess. You don't really want it. but that's a bad name. It is the plan that was generated by the optimizer, so it's a good plan. It's just missing a few bits of information. So if you've got a really huge query or a really long-running query and you don't want to try to execute it to capture the actual plan, that's okay. You can generally see how it's behaving by capturing the estimated plan, so it's worth doing. Now we're gonna go over pulling plans out of Management Studio and pulling plans out of the procedure cache. We won't have time today to get the extended events, and I'm not going to show you how to do trace events. You're on your own there because I don't think you should do it. So moving on. So we're going to start reading execution plans. Now what we've got here is a very simple plan. It's really straightforward. But even looking at this really simple plan, the question is where to start. Do we start over on the left? A lot of people say that. Do we start on the right? Other people say that. Do you look for anything in particular? Is there anything bad in this plan? Is there anything bad in any execution plan? This plan's pretty easy. You can take a look at it. You can glance through it with your eyeball, pretty much assess everything in it, and have an idea of what's occurring, just guessing based on the information presented. But if we get an execution plan that looks like this, then things are different. Now, this particular execution plan was the winner of the Hairy Execution Plan contest at last year's SQL Cruise. SQL Sentry, a great company, has a great piece of software called Plan Explorer. Is one of the hosts of SQL Cruise. My company is as well, Redgate Software. But they have a contest where people bring in execution plans, and the hairiest, or as you can see, most complicated plan, wins. So let's say that you're on this plan. Where do you start reading this plan? Well, you can start just about anywhere and figure this plan out. Where do you start when you're reading this plan? And that's the question. So I'm going to tell you, my personal opinion is you start with the first operator. Now let me just run back here for a second. We'll cover this again when we do the demos. The first operator is that little green select operator all the way over on the left. That's the first operator. That's where I start. Let me tell you why, because there's some fascinating information in this. The first operator has a whole bunch of properties. Now, if you just look at the tooltip, well, we'll talk about tooltips in a minute, but the properties in the first operator are important. Some of the things that are there, plan size, how big is this plan? How much memory is it consuming? Now, if you're having performance issues, memory could be an issue. You may want to know, okay, well, we're getting lots of these plans that's ad hoc queries, so therefore every query gets a new plan. But these plans are huge. Maybe it's impacting our memory. We need to take a look at that. You want to look at compile time, which is stored with the plan in that first operator. How much CPU and how long did it take to get this thing compiled? Now, most plans are very, very quick. I mean, extremely so. But I've had issues where I had a 5-minute compile time on a query, and I've heard of longer ones. I've heard of query plans that took half an hour to an hour to compile, and that's a huge, huge hit on performance. So it's worth knowing how long that took. The amount of memory that the optimizer thought this plan, once executed, would consume, the memory grant, is also there. There's also information about missing indexes, if any, on the query. You get the optimization level, which is really important. Is this a trivial plan, meaning that the optimizer said that there is only a single way that this plan could ever be executed? If so, that's going to show up in the optimization level. Or did it show optimization level full? Or, like the winner of the Hairy Execution Plan contest, did it show the optimization level was error? In which case, oh my gosh, we have problems. There's issues there. Even though it optimized, went through the optimization process, there's definitely problems going on inside the plan. Also, stored in this first operator, remember, all these things are stored in the first operator, is the compile time values for any parameters passed to the plan. And if you capture an actual plan, you also get the runtime values. Now, the runtime values are extremely important because what you want to be able to do is compare compile time value to runtime value. And when you hit a situation such as bad parameter sniffing where you think something should only be returning 50 rows, but it's returning 50 million, or vice versa, 50 million to 50, and you get different execution plans, you're going to want to look at these compile time and runtime values and then compare those to your statistics as a way for troubleshooting bad parameter sniffing. Also, we get the query hash, which is more or less a fingerprint for that query. The query itself is hashed into a single value, and then that value is stored. Now, if you have lots and lots of ad hoc queries coming in from a reporting system or something, and you identify a common problem, an existing issue, and you fix it in one query, you may want to go in and look at the plan cache, run a query against the plan cache for that query hash value, and see if you have other queries that are also using that same pattern, because you may have other places to take a look at and figure out. Another thing is the reason for early termination. Now that can be, again, there could be an error, interesting. There could be a situation where the reason for early termination is timeout. Now timeout is interesting, very interesting, because what it means is that the optimizer more or less gave up. It stopped trying. So if you see reason for early termination timeout, that means that it's gone through a series of optimizations, but it stopped. It decided that it just couldn't. Grant's voice cuts in and out at times. Sorry.
Yeah,
Is that a
I
single
saw that too.
microphone? Oh, you are seeing that too?
No, what I was saying, I saw that note,
Oh,
but
okay, the
but it
question.
didn't sound good to me, so I'm thinking it may be something on Andy's side.
Okay. Sorry, I'm trying not. I'm not doing anything that would make it cut out. Another person says they don't have an issue. Okay, so I'll keep going. So in the reason for early termination, you could get good enough plan found. Now what that means is that during one of the optimizations, the optimizer decided, you know what, based on the mathematics that it maintains within itself, it's decided, hey, I've got a good enough plan here. I'm going to stop optimization and release this plan to you. It may not be a perfect plan, but it's good enough. And that's what the optimizer goes for, is good enough. And off it goes. That's a good thing to find. If you don't have a reason for early termination, but you do have an optimization level full, that means that the optimizer went through full optimization and returned the best plan it could find. It wasn't a timeout, and it didn't short circuit for a good enough plan. But so that's not a bad thing, it's just informative. If there's no reason for early termination, don't panic, it's good, right? That's a fine thing. Now, also stored inside this first operator, and I mean this first operator is overloaded, it's got all the good data, is the ANSI settings that were used to compile the plan. Now why is that interesting? Well, because different ANSI settings can result in different execution plans. Yeehaw! So if you ever hit the situation where you're a developer, you write a good query, you test it out, it looks fine, you pass it over to the data DBAs, they run the query and it comes back with a different execution plan and it doesn't work well at all. This is a situation I've hit several times myself. You should take a look at the ANSI settings. It's possible that your local ANSI settings and the server ANSI settings are different, and you could be getting different execution plans because of that. So this is all useful stuff, all in the first operator. Now I'm going to stop here just in case there's any questions about the first operator in particular, but I do see that there is one question. Can you run execution plans in production environment? Well, let's put it this way. There are execution plans in your production environment, and you can pull them out of cache, and the cost of doing that is extremely low to the point of zero. Not really zero, nothing is free, but it's as low impact as you can get. To capture an actual plan, that means you have to execute it. So I would prefer if you did not execute anything in my production environment if I was doing it. So yes to capturing estimated plans, yes to pulling plans out of cache, but generally no to running the queries in production to capture actual plans, unless you have to. Again, there's situationally you may hit that situation. All right. What version am I running a screenshot of? The version right now, that one is 2012, I believe, that little screenshot. But it looks almost identical in 2014 and 2016. 2005 looks the same, as a matter of fact, or real close. There's a few differences, but not very many. All right, so starting with this plan again, remember we mentioned left or right to left. Well, it's a good question. First clue is English. The people who wrote this program, we can assume, and it's a fair assumption and accurate, by the way, but we can assume that they were probably English-speaking and Western-oriented, and English is read left to right. So probably the way that they intended execution plans to be read is left to right. However, we have another clue, and that's those little arrows moving over from right to left. And so the question still remains, are we going left to right to left? I don't know. Answer is, of course, both. Both are correct. The left to right represents the logical processing order. That is absolutely the way that was intended to be read. There is a select, let's go back over to here, this query. There is a select statement. It is retrieving information from a merge join. The merge join is pulling information from a clustered index scan and a sort operation. Just so happens the sort operation is pulling information from another clustered index scan. And that's the logical processing order left to right. Now, interesting enough, those little arrows, those pipes, and I call them pipes, they're data pipes, it's moving data through the plan, those are moving the other direction. Whoops. That is the physical processing order. So physically, there is a clustered index scan against the state province table, and it's that is pulling information off of disk. There is another clustered index scan off of the address table, and that is pulling information off of disk. The information from the address table has to be sorted before it moves into that merge join operation, and the merge join operation moves both those pieces of data together and spits them out as a select statement. So from a physical standpoint, it goes the other way. You need to understand both directions in order to read certain plans. Some plans are going to have certain operators that jump around actually within the plan, and so you need to understand from a logical or a physical standpoint how this plan is being generated, how the data is moving through there, and what the logical processing order is. So both answers are correct. It's just, are we looking at it from a logical processing order or are we looking at it from a physical processing order? Any questions on that? I don't see any.
No, either.
Okay, moving on. So what else do we look for? Right, it's pretty easy. We're going to start with that first operator. Absolutely, no questions asked. That's where all the good data is. Next, we're going to look for warnings. Warnings are easy to spot. It's that big red X or a yellow triangle. If we see a warning, that's a concern. That's something we should look for. It's an additional bit of information. It's something else that it's a poke in the eye is the best way to think of it. This is someplace your eye should be drawn to, and you should identify what it is and why it's there. That's not to say that this is a bad thing. It may not be. There's all kinds of things you can do inside your queries that could generate a warning or an error that you're doing with intent, and that's okay. But this, when you're reading an execution plan, this should be something that draws your eye pretty much immediately after you've looked at that first operator. We're also going to look for the most costly operator. You see in the screen here, this operator cost is 96%. Without a doubt, inside a standard execution plan, this is the highest cost operator. But you need to understand in either estimated or actual plans, it doesn't matter, those costs are estimates. That's not a measure of performance. It is an estimated value. And that estimated value, it's not, perfect, right? Because it's not giving you an exact definition of how much this costs. It's giving you an estimate of how much it thinks it's going to cost. However, they are the only numbers we get, so we are absolutely going to use them as guideposts. Just understand that they are estimates. You're also going to look for fat pipes. Some of the pipes are very, very thin. Some of the pipes are thicker. These are not bad things. it's just an indication of load. The bigger the pipe, the more data being moved through the system. So what we want to look for, though, is not so much big pipes, although that is something you look for, but you're also going to look for transitions. If it goes thin, fat, thin, fat, thin, fat, that's usually an indication of something going on that you really, really, really need to focus in on and understand, why is this doing this? If it's going really fat and getting thinner and thinner and thinner as the plan moves across in the physical order from right to left, what you're seeing is late filtering. So it's reading a lot of stuff off disk and then filtering it later in memory. That's a problem. That's a performance issue. You want to filter more off of disk than in memory. If you see thin pipes going to fat, 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 it's multiplying data as it goes across. This is not always a problem, but it's an indication that we're moving way too much information and we're adding on to it as we go along. Tuning opportunities there are not necessarily really good. You actually need to change business logic and stuff, and that gets harder to do. The next thing we want to look for is extra operators. Now, I've gotten in trouble for this before, but I'm going to continue describing it this way because everyone remembers. What's an extra operator? Well, in the 1970s, there was a court case in the United States, and it went up to a circuit court judge, and he was asked to rule on what defines pornography. And the way he defined pornography was, I know it when I see it. Now, what's an extra operator? I know an extra operator when I see one. If you don't know why an operator is on your execution plan, that's an extra operator. If you don't know what an extra operator is, like there's a question up there right now that says, what's a key lookup operator? For you, that will be an extra operator. So if you see an extra operator, if you see porn, I know it when I see it. If you see an extra operator, you need to look at that to understand, why is that here? What is it doing? If you've answered both those questions, that operator is no longer extra. It's now defined, and so you can move on. Now, again, that's not to say there might be issues or not, but if you don't know what it is or you don't know why it's there, that's something you need to look at and take into account. Another thing we look for is scans. Scans are not necessarily bad. Seeks are not necessarily good. It really depends on the rest of the plan and the amount of data being moved and all kinds of other stuff. Don't get hung on scans, but scans are absolutely an indicator of data movement. It means they're hitting our production server hard when we have a scan. So we're going to want to go in there and understand why we're getting a scan, what's happening, how is this occurring, and so it's something that draws your eye. And then the last thing, is we're going to look at estimated versus actual. Now, if you remember, I said there's estimated plans and actual plans, and the main difference between them is a few properties. Well, one of these really fascinating properties is the actual number of rows. Another is the actual number of executions. We're going to want to compare the estimated number of rows to the actual number of rows, the estimated number of executions to the actual number of executions. Making these comparisons gives us an indication of what's going on. In the little example that popped up, the estimated number of rows is 1.6, and the actual number of rows is 400. And so this is an indication that possibly my statistics might be off, or there are other possible issues. There's a whole bunch of different stuff it could be. But that right there, that disparity, is what I'm looking for. Now, if the disparity is the estimated number of rows is 1.6 and the actual is 3, who cares, right? It's got to be real disparity. This is 1 to 400. That's disparity. 1 to 2, 1 to 5, even 1 to 10 is not necessarily that big a deal. But 1 to 400, that's something that you get concerned about. So all of these are just indicators. None of these is bad. None of these is broken. None of these is, oh my God, my plan is on fire. But every single one of these is an indicator, a way to draw your eye, the first things that you should be looking at after you've looked at that first operator. Now, questions. Let's go back here. Is a cached plan an actual plan or an estimated plan? A cached plan is the plan used to resolve your query. So technically, it is an actual plan, but the plan that is cached has no actual measures. Therefore, it's an estimated plan, which means I didn't answer your question at all. It's what's stored is an estimated plan, but it is the plan used by the query, so it is the plan used. So calling them estimated or actual is a bit misleading, but that's Microsoft's terminology. So we kind of got to stick to it. What do you do if you have COT's product and you cannot make any changes to the code? Looking at execution plan, not clustering looks makes a difference. What can you do? Well, if you can't make any changes, you're kind of stuck. Yeah, you're stuck. I mean, if it needs an index and you can't put one on, well, there's no way to not put an index on, but put an index on. You're going to have to make a choice. I'm not going to dig that hole today, though, so we're going to move on past that one. All right. Any other questions around this role? Where do you find the actual number of rows and the actual number of rows to compare? Great question, Robert, because that leads us, I believe, into the next thing. So where do we look for this information? Robert, your check is in the mail, babe. So the first thing we have is tooltips. And again, I'm going to demo everything that we're talked about so far. We're going to do a demo of it and walk you through it so you guys can see it in action. So it's not divorced from what we're talking about. The first thing you look at is tooltips. If you hover your mouse over a graphical plan, you get these little tips that pop up, and they're okay. It's kind of interesting. So this is a tooltip for a table spool operator. But where's the good information? The good information is in the properties. The properties give us a lot of help, a lot of driven information about what's going on. We get scads more data. Is some of the data the same? Yes. Could we use the tooltip for certain bits if we're only looking at peripheral information? Yes. But I'm gonna in the demo you're gonna see exactly how useless the tooltip can be. So I've gotten into the habit of making sure I've got the properties available all the time. I don't want to rely on the tooltip having the information I want, and then, oh gosh, it doesn't have it, now I better go to the properties. I just go to the properties. It just makes my life easier. I just find it an easier way to deal with. No questions on this one because we're going to go right into the demo and you guys will see what's going on. So let's switch over to here. And let's start a new query. And let's make it so it's visible. How is that? Is that big enough? Everybody can see that, I assume?
That looks great.
Okay, great. So we're going to pull from, let's do select star from product details. Oh, wait, no, let's sales order details. That's what I meant. Cool. So the way we turn on execution plans, oh, Zoom, it's not started. Oh my gosh. Hang on one second. Bad presenter. And we're not live, so no one can yell at me. All right, so the way we do execution plans is you've got a couple of choices. If we just want to capture an estimated plan, we've got it right here. It's right up on the toolbar, or you can hit Control-L. Now, if I do go over here, put the cursor back here, and hit Control-L, it's going to immediately bring me back an execution plan. Don't worry about some of the extra windows. I'm testing a whole series of softwares right now, so you're going to see a few things on here that are not normal. So it brought me back an execution plan. Now that execution plan is not, whoops, uh-oh, my server froze. Are you guys still there?
I'm here, and I can see your screen, but
Okay,
it's frozen.
good. Yeah, it is. Oh, interesting. Hang on one second. The demo gods are not smiling. Uh-oh, I see something bad. Your PC ran into problems and restarted. Oh no.
Wow.
Oh wow, server went completely down. Hang on one second. We can cheat a little. I'd like to. Lost my mouse. There it goes. All right, let's minimize that. Hang on one second, guys. Let me see if I've got an Azure VM running. I don't think I do, but maybe I do, and we can just switch over to that real quick. Otherwise, I'll talk you through a little bit more of the slides, and then we may just have to call this demo a little, we may call this one a little short, which will suck. I am so sorry. This is the first time this happened on my laptop. Again, I don't think I have any Azure portals ready, but let's just, or Azure VMs ready. Let's just check though. Give me one second, because that's clearly unhappy, so we're going to let that go for now. Well, hang on. While the Azure portal is coming up, we'll keep going, and also I'll answer, actually, why don't I answer a couple of questions? What about plan guides? I'm assuming that's in reference to the person who wanted to add indexes. Yes, you can use a thing called plan guides to force a particular plan or to force query hints onto queries without modifying those queries. But the question he said was, well, if we look at the plan and figure out that there's an index we need, but we can't modify anything, what do we do? And really the short answer there is there's nothing you can do, because if you need an index, you need an index. Plan guide will not put an index in place for you. Let's see, which IntelliSense add-on are you using? It's a tool called SQL Prompt from Redgate. I lost all audio. I'm assuming that's not the problem.
No,
Please
I
keep
mean
going
I
with the
can hear
slides
you.
if demo does not come back. Yeah, we're definitely going to keep going with the slides. Don't you worry. I'm just, if I can get the demo in place, I'm certainly going to do that. The slides are already uploaded. They're available at slideshare.net. Come on, Azure. Of course, Azure's acting slow today too. All right, well, let's talk for a minute about querying the plan. Query for the plan. So again, the question came up earlier about can we run these things against production? And this is something that I recommend everyone get permission to get against production. This is running against System Exec Query Plan. In conjunction with System Exec Query Stats, System Exec SQL Text, and I can pull together the query plan. More importantly, I can pull together my last execution time, my execution count, all the kinds of fun stuff, and I can pull this thing together and look at these things and pull execution plans straight out of my plan cache and then look at those. So if I've got a query that's running slow right now, I can query the plan cache and see the plan for that, because a query will not execute until the plan has been compiled. So the plan will be available for a query that's running slow. So this is a great way to go into the cache, get those queries, get the information out. And so you're going to look for that. This is what you can do to pull queries directly out of cache. You do need to have view server state and view database state. I would strongly recommend that you talk to your DBAs and get those permissions on production. I think that those are good things. However, DBAs, if you're listening, give them this permission. However, educate them about the indexing dynamic management views and tell them to not use them or you will revoke your privileges, because those things are actually a little bit dangerous. You can do some damage there. Not these are very safe, but the indexing DMVs are a little unsafe. So I would just expose but educate. Great way to go. So any questions on querying plan cache? Let's see. Somebody can see the slides. What are some tips for tying a particular operator to a specific spot in the query? Well, basically, the operators themselves are going to tell you which spots within the query that they are answering. So for example, you reference address as a table, and you see the primary key for the address table being scanned inside the execution plan. It's pretty immediate which part of the query is represented by the execution plan. And most of the rest of the plans work that way. Now, there's a bunch of operators that don't. And it's more or less the operators between the interesting operators. So for example, if you've got a scan or a seek, that's going to be against the table, and you'll be able to look and see, okay, well, I'm referencing that table. And you'll know which columns are coming from there and all that fun stuff. But if you have a table spool operator, that's not something that's in your query. So you'll have to look at that to understand why is it being generated, where is it being generated from, and then marry that back to your query. So that's the part of reading execution plans we would get into if I could do the demos. And what kind of permissions do I need to grant? It's data reader, I'm sorry, not data reader, sorry. It's view server state and view database state. Those are the permissions you need. And unfortunately, no, I don't have any Azure VMs running right now, so we're going to have to ignore that. Let me just check one more time, see what's going on with this thing, if it's back online. No, and it's going to be a little while, obviously. All right, so that's dead. Now, if we've got really big plans, like that hairy execution plan winner, that had several hundred operators in it. So looking for the highest cost operator from that plan is going to be very difficult. It's going to take a lot of time. So instead, every single execution plan, 2005 and up, is XML under the covers, which means we can run XQuery against it. We can pull the XML data straight out of it. So the query you see right in front of you there uses XML namespaces and then runs a query against the XML namespaces to pull the physical operator name, the node ID, the CPU and I/O for that node, and all the costs, and pulls it all together inside of a single query. Now you can run these any way you want to, pull together as much as you want to. My blog, scarydba.com, has a whole series of demos, and we could definitely put those together and run those. This is a great way to pull information out of really big execution plans. So if you've got big execution plans, you don't want to necessarily browse through the browser. Instead, you can run against these other run the XML. I'm totally distracted by the fact that this demo went south. And it's so funny because before you guys all came online, we were talking about another instance where the demos went south. So any questions on the X query? Any chance the demo could be done some other day? If you guys will have me back, I would be glad to come back and do this presentation again. So no problem.
To kind of interrupt you, if you don't mind,
Not
we
at
can
all.
always have you back. So maybe if you want to come back sometime next month or later in the month, just let me know. I'll email you, and anytime you have time available, we'll set up
I'd be
another
glad
webinar.
to.
Oh man,
Yeah,
thank
I'd
you.
be glad to. And again, I apologize to everyone. This is the first time my laptop has ever acted up. This laptop's a year old, and it's been a beauty. By the way, it's a Toshiba Portage, and I recommend it, at least until today.
So what I could do is like say a part two. We could have this, session part two. How's that sound?
Sure.
Oh, that'd be wonderful.
Yeah.
Thank you.
Well, yeah. Any way you want. I know getting speakers is always a bear, but I at this point I owe you guys. So we'll figure out how to do it, and we'll get the advertising out so we can do it
Sure.
again. Some references, and I'll tell you what we can do. We can still do an hour, but we'll kind of skip over really lightly the intro, and then we'll just go and do lots more demos.
Oh, that'd be wonderful. Thank you.
Okay. Sure, absolutely. So some places I recommend you guys to go for some more information. There's a free book, Performance Tuning with SQL Server Dynamic Management Views by Lewis Davidson and Tim Ford. It's a little bit old. They need to update it, but it's still very useful. It's got great information in it, and it's free. So you can download it for free on the link. But my book, SQL Server Execution Plans, make sure that you're using the second edition. We're working on the third edition actively, so we'll be getting that done. I strongly recommend you pick up the Internals book by Kaylin Delaney and et al. And also SQL Server Query Performance Tuning, not the 2012 book. Good gosh, who put that in here? My other book on query tuning is very good. Let's fix that now. And I'll fix the link later. Oh, and I just managed to break everything, didn't I?
Wow, yeah.
Hang on. There we go. Fixed it. All right, so my other book on query performance tuning is also has a lot of stuff on execution plans. Now, obviously, we kind of messed up a little bit on the goals because the demos were going to seal it home on all the stuff that we talked about. But just to go back, you want to start with the first operator. You want to look for any warnings. You want to look for fat pipes. You want to look for operator cost. You want to look for porn or extra operators, right? Extra operators that you don't know what they are or why they're there. And let's see, weird transitions on the pipes, and that's pretty much it. I apologize for the demo crashing, but are there any questions on that we can cover without looking at the demos right now on any topic? Go ahead, guys. This is your time, and I support you still being here and being patient. All 177 of you.
Well, just I want to throw out a thank you for everyone attending. We had over 213 people at all parts of the meeting today, so that's a wonderful number. Wow. So I know Grant like to know, I mean, how many people show up, so that's wonderful. Thank you.
Right, absolutely. Again, we will figure out when and where, but we'll get a part two. We will advertise it. He'll go off his mailing list, and I'll make sure that we give it out to others. But any other questions you guys want? I mean, you've already set off the time, so if you want to talk about it, let's get up to some information. You don't see the XML query on my blog. Do a search for XML queries. There's about 20 of them or so on my blog, so at various posts. It's not all in one spot. How do I get included in the mailing? Sign up with the virtual chapter.
Yeah.
I think you're training. What the fix is if the plan is bad? Well, interesting question, because there is no such thing technically as a bad plan. The plan is the plan. The plan is showing you what's going on. The behavior could be problematic. And so what are the fixes? It really depends. You've got to look at and understand what's going on. So let's say we've got an indication, there's an index scan, and we know we've got a good index. There's not a question of whether or not there's an index there. There is. But we're still getting a scan. We're not getting a seek. Well, why? The issue could be a number of things. What are we going to look at? We'll go into the properties of that scan and look and see how it's filtering and where is it filtering, if it's filtering at all. And if it's not filtering in the scan, where else in the plan could it be filtering? If it's filtering someplace else, why is it filtering someplace else? And the indications, it could be any number of things. We have bad statistics, so it thinks, hey, it thinks there's only 10 rows in the table, but there's 10 million. Well, with 10 rows, a scan is cheap, so it goes and does a scan. With 10 million rows, the scan is very expensive. So we just need to update statistics. If you look at estimated versus actual, you may see that. It could be that you've got a function on a column in your where clause or your join or your having clauses, and that causes it to not be able to use statistics. It won't use the good index you have, and it will go back and start doing scans against it. So it's all these things are going to happen, and you just figure out which and where, and it's a matter of looking at the plan to understand that. Let's see, what can you talk about index internals? Not today. Totally different presentation. Actually, you know what? I don't have one on index internals. Thank you. That's one I should get. I need to write myself up one. I can talk on index internals. I don't have a good presentation for that. Is it good to include the included columns in the actual index? Well, yes, depending. If you are trying to solve a key lookup issue where it's causing problems and you have 3 or 4 columns, let's say that there are integer values, and by adding those to the index, you'll expand the index size a bit, fewer rows per page, but you get seeks against that index and no additional lookups against the clustered index. That's an awesome solution. Let's say that those are 3 varchar 250 columns. Suddenly it doesn't look as attractive. Dance around, there's no like instant, this is good, this is bad. In general, the use of include columns is wonderful if they're done correctly. How are they helpful for a query plan? Oh, index internals. Well, knowing how indexes work is not so much useful for the query plan, but it's useful for tuning. Can you explain the importance of cost? Yes. Well, first off, remember, all costs are estimates. It's the most important thing to get out of the whole thing is costs are estimates. So they're not measures, but they're the only number we get, and it's what the optimizer thinks the costs are going to be. So it's a great indicator for where the optimizer sees issues. So the higher the costs are for the optimizer, probably in most circumstances, the higher the costs are for you. So it acts as a signpost for us tracking down where the most costly operators are is generally where the problems lie. How important is defragmenting indexes? Well, again, that's one of those it depends answer. The depends is, are you doing point lookups or scans? If you're doing point lookups, fragmented index kind of don't matter. By point lookups, I mean 1, 2, 3 rows, a page worth of data. Go and get this page of information. That is extremely cheap even with a fragmented index. If you're doing scans, suddenly fragmentation is the worst thing in the world. So, that's pretty much your answer. How do you determine if a spool is bad? Yeah, spools are not bad. Spools are actually very, very useful. What a spool is instead of going to disk over and over and over again, what it's attempting to do is load some data into a temporary storage space, a table spool, and then use that table spool over and over again throughout the plan. In instances where there's only a small amount of data, this will stay in memory, everything is awesome. In instances where there is large amounts of data, this will end up spilling out to TempDB. Yay, TempDB, the dumping ground of SQL Server, and that can be a problem. So it really depends on how that spool is used, why it's being used, and how that data is being, the issue. So how do you detect sniffing from the plan? Okay, now this is fun. You can't detect parameter sniffing from a single plan. You need 2. You need the plan that's quote-unquote good and the plan that's quote-unquote bad or problematic. The plan that's fast and the plan that's slow. And then you go to that select operator, that first operator, and it shows you compile time values. You get the compile time value for the 2 different plans. You take a look at the statistics for that value, and that will tell you why you're getting 2 different execution plans. And then it's up to you to figure out, how do I fix this bad parameter sniffing issue, and is it I need a specific plan or I need a generic plan? I've got a 1-hour session on how to do that. So there's a lot to cover there. We'll do that another day. So if you can't run Victor, if you can't run queries, you can't get actual plans. There's no way. The main difference between the estimated and the actual is about 6 properties. Mainly the one you're interested in is the actual number of rows and actual number of executions. That's the really fascinating bit of information. If you can't get that, you can go without it. What you'll have to do is go in there and look at the estimated number of rows and say, okay, well, great, it estimates 1 row. If I pass in my standard value of 42, how many rows do I get back? 1 million. Huh. Okay, I don't trust this anymore. Let me figure out why it thinks it's only going to get 1. Is there a problem with my statistics? Is something else going on? But estimated plans are awesome. Don't dismiss them. They're a great way to get information. Permissions needed. It's view server state and view database state. What to consider to fix, estimated versus actual. Either. I don't shy away from either. I prefer to get actual plans because of those few extra bits of information, but I don't need it. I can look at just estimated plans and do most of my tuning. Is it possible to say more about when scans are good? Sure, it's pretty easy. If it's a small table, if it's let's say it's a single extent, right? 8 pages. A scan is so fast. It's so easy. And if you're sitting, your table fits inside of a single extent and it's doing scans, great. Don't worry about it. Let's look at another situation. Select star from table. The worst thing in the world would be to have a seek on select star from table, because that means that it's going through the B tree, not balance tree. I didn't say that. No one heard that. It goes through the B tree over and over again to retrieve the information, and that's not a good thing. So you don't want seeks when it's reading all the data. In that case, again, a scan is good. Situationally, there's a whole bunch of other stuff, but that just gives you an idea of some generic things to look for on when it would be okay to have scans. Let's see. Is it good practice to set up free proc cache? No, it is a horrific practice to free proc cache on a regular basis. Don't do that, don't do that, don't do that. Are you hitting situations where you've got some queries that it hit bad parameter sniffing? Great. There are ways to target those for recompile. You can either use a recompile query hint, or you can use free proc cache and target the specific plan handle to retrieve those things out of cache. But freeing proc cache, nuking your entire cache, is basically saying, hey, I'd like to see a CPU spike every 20 minutes. It's really bad practice. Don't do that. Are there actual operator costs or actual subtree cost metrics to go along with estimated? Yeah, there's no actual operator cost, none. It's estimated only. So there's no actual, John. Shouldn't we avoid eager spools and bigger sets of data? If you can, yeah. I mean, again, if you're hitting that, you've probably got some structural issues or some query issues, but it really depends. It's down to how the optimizer is resolving that stuff, and so it's down to what you have for indexes and data movement and all this other stuff. Remember, spools are not bad necessarily. It's just a use that is problematic, and so it's something to look for and deal with. Is cost equal CPU? It's I/O and CPU is actually what the cost is, but it's estimated I/O and estimated CPU. Don't think of it as I/O and CPU. Think of it as cost units, because it's a meaningless number. Have continuous monitoring process that use plan cache to identify likely performance issues. Yes, there are ways to do that. That's way more complicated than I can start talking about here. It's down. Frankly, the way to do that is, if you are able to use Azure SQL Database, you can use this thing called Query Store, which is awesome. If you're ready to move to SQL Server 2016 when it moves out, that will also have Query Store. But right now, today, you would have to build your own version of the Query Store, and there's ways to do it, but it's a bear. Is Column Store Index solution for performance issues? Yeah, Column Store Index is a great solution for performance issues, depending on the performance issues you're having. If you're having performance issues that involve point lookup operations, index seeks, then Column Store is a horrific solution. However, if you're doing any kinds of aggregates, this is a great thing for column stores. Now, column store operator is going to show up in a plan as a column store operator. It will be a clustered column store scan or a clustered column store lookup. You will see specifically, it will tell you that it's clustered column store. But one thing you need to do, you need to look at the properties of that column store and look to see if it's doing batch mode or not. If it's doing batch mode, yay, you win. If it's not doing batch mode, then you're not getting the benefit of that column store index. What's a rebind and a rewind? Are they good or bad? They're not good or bad. Rebind and rewind is, a rewind is that it's got a data set and it's going back to the beginning. You'll see it a lot in loop joins. And if you think about how a loop join works, it just makes sense. A rebind means it had to go and get the data a second time. That can be more problematic. Let's see, is high cost for one step bad, or is that the reality of data retrieval? High cost for one step is the reality of data retrieval depending on what's going on inside that query. What's your view on which SQL Server should be restarted? Um,
Hmm.
Tough one. Now, if it's SQL Server 6.5, we restarted once a week. No matter what, it would die otherwise. SQL Server 2000 and above, I worked for an insurance company that was also an engineering company. Once a year, we restarted every single server on the place, and we had SQL Server instances that were only restarted once a year. Now, the reason we did it once a year was because they found that a restart is where you're most likely going to get hardware issues. So during a restart situation is when the disk is going to fail, or when the controller is going to fail, or when some piece of wire is going to burn out, somewhere in the system. And so once a year, we had all the hardware vendors for all our hardware standing by with spare parts, and we would reboot all the machines, and anything that broke, we would replace it on the spot. So how often do I think they ought to be done? At least once a year. More than that, it seems crazy. Okay, so it's now 2 o'clock. We're going to skip past the last couple of queries. They're definitely getting out in the weeds. So,
Okay. Uh,
but I will come back and do this VC again, guys. I feel really bad that my demo's crapped out so badly on you, and it's still not fixed. So,
wow. So, so I just want to thank you for coming. I mean, just to answer questions, part of your presentation is great. There's a lot of great knowledge there that you may not cover. So, thank you.
cool. Well, thanks. Well, and again, thanks for everybody coming out, and I really appreciate the time.
So, I'm gonna just to let everyone on the chapter know. I'm gonna go ahead and email Grant tomorrow, and at his time frame, we'll have another meeting. And if it's later in the month or early next month, whenever Grant can do it, we're going to have it. So thank you, Grant.
Great.
So
Thank you.
so for everyone else, I captured the information and I'll put it on our website. And um, I have a meeting actually for next month too, just to let everyone know. I haven't gotten the official title yet, so as soon as I get more information on the December meeting, I'll post it. So y'all have a great day, and I'll be talking to y'all soon. Bye, Grant.
Great. Bye. Thank you.
All right.